In part 3 of our lesson on trigonometric equations, you will learn to solve by quadratic methods, which means we'll do FOIL factoring or use the quadratic formula. In this first example, we have to solve on the interval 0 to 2 pi. As soon as you see this, you know you're going to be giving your answers in radian measure. The equation we're given is 2 sine squared of x minus sine of x minus 1 equals 0. Now, remember back in your Algebra 1 days, you would get equations that look like this: 2a squared minus a minus 1 equals 0. And you learn to do FOIL factoring on those. We know that in order to get 2a squared, we'll take 2a times a. In order to get 1, we need a 1 times 1. And then we have to get our plus and minus sign correct based on the middle term. So we need minus a here in the middle. So that tells us the 2a needs to be negative and the 1a needs to be positive. So we will do 2a plus 1 and a minus 1 in order to get the factoring for this. Now the same thing is going on in this equation, but the a has been substituted with sine of x. So when you're looking at this equation, you know you're going to FOIL factor. You know the only way to get 2 sine squared of x is to take 2 sine of x and multiply it by sine of x. The only way to get 1 is with a 1 and a 1. We need the middle term to have a coefficient of negative 1, which means this outer term needs to be minus 2 sine of x, and the inner term needs to be plus 1 sine of x. So there's our factoring. Now by the zero product property, we know that 2 sine of x plus 1 will have to equal 0, or sine of x minus 1 will have to equal 0. In each case, we will need to isolate the trig function. So let's take care of this first equation. We will subtract 1, and so now we have 2 sine of x is equal to negative 1. Then we will divide both sides by 2 and get that the sine of x is equal to negative 1/2. We need to take this equation and draw a picture of it. So sine of x is negative. So that tells us that we are going to be in quadrants 3 and 4. Next, we go to our special angle chart, and we look up the row where sine is 1/2, and we see that our reference angle is going to be pi over 6. So we put the reference angle in quadrant 3, which means we would start at pi, add pi over 6, and we're going to end up at 7 pi over 6. If we put the reference angle in quadrant 4, we know that means we would start at 2 pi, subtract pi over 6, and end up at 11 pi over 6. So from this piece of the equation, we are going to get that x is equal to 7 pi over 6 or 11 pi over 6. Now we turn our attention to this piece of the equation. Isolating the trig function, we see we are going to get sine of x is equal to 1. Now we can draw a picture. We know that the sine will only equal 1 here at pi over 2. So from this piece of the equation, we will get that x is equal to pi over 2. So the equation that we started with has 3 total solutions: 7 pi over 6, 11 pi over 6, and pi over 2. In this example, we will solve on the interval 0 to 2 pi, so we're in radian measure again. And our equation is that secant squared of x is equal to 2 minus secant of x. And again, just like in your Algebra 1 days, we have to get everything on one side and then factor. So let's leave the secant squared of x on the left-hand side here because it's already positive, and that's a good thing. We like our squared term to be positive. So we have secant squared of x. Now over here, this is a minus secant of x, so it will become plus secant of x when it moves to the left-hand side. The 2 is positive, so it will turn into minus 2 on the left-hand side. And don't forget, you have an equation, so you have to get in equals 0. Every equation always has to have two sides: a left-hand side, an equal sign, and a right-hand side. Now we are ready to do our FOIL factoring. The only way to get secant squared is to take secant of x times secant of x. The only way to get 2 is to do 1 times 2. This is a minus 2, so we know one of the factors will be positive and one will be negative. Because our middle term is a positive 1, we know that means we need the 2 secant of x to be positive and the 1 secant of x to be negative, so that 2 minus 1 is 1 secant of x. We will apply the zero product property, and we will get secant of x minus 1 is equal to 0, or secant of x plus 2 is equal to 0. We'll start with this equation and isolate the trig function. So we get secant of x is equal to 1. Most people tend to think more quickly in terms of cosine, so let's go ahead and convert this, and we get that cosine of x is equal to 1. We can draw this picture, and we know that cosine of x is equal to 1 only here at 0. So the solution to this first piece is that x is equal to 0. Now let's turn our attention to this second equation. Subtracting 2 from both sides, we will get that secant of x is equal to negative 2. Once again, we'll want to convert this to cosine, So we get cosine of x is equal to -1/2. We can draw this picture. We know if cosine of x is negative, then that means the angles have to be in quadrant 2 or 3. We go to our special angle chart and look in the cosine row for the value of 1/2, and we see that theta r is going to equal pi over 3. Here's pi. Now in quadrant 2, we will start at pi and we have to back up by pi over 3. So pi minus pi over 3 is going to be 2 pi over 3. In quadrant 3, we will start at pi and go forward by pi over 3, which means we have to add pi over 3. So pi plus pi over 3 is 4 pi over 3. And from this piece of the equation, we are going to get that x is equal to 2 pi over 3 or 4 pi over 3. So this equation has 3 solutions: 0, 2 pi over 3, and 4 pi over 3. In this next example, we are going to solve on the interval 0 to 360 degrees. So when we give our angle answers for this one, they will be in degree measurement. The equation we're given is that tangent squared theta is equal to 5 minus 2 tangent theta. By now, we probably all feel pretty comfortable knowing we have to gather up the terms, and we'll want to do it on the left-hand side since the tangent squared is already positive there. So we're going to get that tangent squared of theta plus 2 times the tangent of theta minus 5 is going to equal 0. Now, one thing to notice right away here is the factors of 5 are 1 and 5, and there's no way to subtract 1 and 5 and get a 2. So that tells us that we know that this is prime, so we're going to be using the quadratic formula. Now remember, with the quadratic formula, if you have an equation in the form of ax squared plus bx plus c equals 0, then you can solve for x by setting it equal to -b plus or minus the square root of b squared minus 4ac, the whole thing, over 2a. Now when we look at our equation that we have, you have to remember that the tangent variable is acting like the x variable over here. So then the coefficient of the tangent squared will be a. So in this case, a is going to equal 1, b is going to equal 2, and c is going to equal -5. So when we look at this quadratic formula, remember that we set x equal to this expression. So over here, it means that we're going to have to set tangent of theta equal to that expression. because tangent of theta in this equation is acting just like the x in this equation. So we're going to set tangent of theta is equal to, now let's start filling in. Negative b in our case is going to be -2 plus or minus. We have to take the square root of b squared, so 2 squared minus 4 times a, which in our case is 1, times c, which is -5, and we have to divide that whole thing by 2 times a, and remember a is equal to 1. So now we have tangent of theta is equal to -2 plus or minus the square root. Well, let's see what happens in here. We have 4. This is going to become plus 20, so that's 24, divided by 2. I suggest to you that you work on the radical off on the side and simplify it rather than have to rewrite a big equation over and over and over again. Now we know that radical 24 has a perfect square in it of 4, and we'll have to take that times 6. So radical 24 becomes radical 4 times radical 6. Of course, that radical 4 turns into a 2, and then we have to multiply times radical 6. So our equation becomes tangent of theta is equal to -2 plus or minus 2 radical 6 over 2. Now this numerator can be factored. We can pull a 2 out. We have 2 times -1 plus or minus radical 6 divided by 2. These 2's are going to cancel. So now we have tangent of theta is equal to -1 plus or minus radical 6. Remember now, this means that tangent theta is equal to 2 different values. One where we're going to add -1 and radical 6, and one where we're going to subtract -1 and radical 6. So my suggestion to you is to take your calculator and put in there -1 plus radical 6, and you'll see that you get 1.4494, a whole bunch of decimal places. My suggestion to you is that you store this, so hit the store button there, and put it in a memory location, say A. Do the same for this one. Let's enter -1 minus radical 6, and we see that we get -3.4494. You don't have to write down every decimal place, just indicate enough, and then let's also store that. I guess we'll put that in B. It's important to understand these are not our solutions. Remember that this means tangent of theta is equal to this number, and tangent of theta is equal to this number. So we still have to solve for theta. So we will get two equations out of this. One where tangent of theta has to equal 1.4494, and another where tangent of theta has to equal negative 3.4494, etc. Now here, we know if tangent of theta is positive, we can draw that picture. We know that means that theta has to be in quadrant 1 or quadrant 3. Now when we grab our calculators and we do the tangent inverse of this 1.4494. Now remember, before we take the tangent inverse here, we want to make sure that our calculator is in degree mode. So hit the DRG button if you need to, cursor under the degree, and hit enter. Now we're ready to take the tangent inverse of 1.4494. So we will hit second, tangent inverse, and to get at memory location A, you will hit memvar, M-E-M-V-A-R, for memory variable, and you will make sure the cursor is under the A and then hit enter. Close your parentheses, hit enter. And rounding to the tenths place, we see that we are going to get 55.4 degrees. So this is going to be our reference angle. We know in quadrant 1 that's going to give us the angle, so that's going to be 55.4 degrees. We know in quadrant 3 we will have to add 180 plus 55.4 degrees. We put that in our calculators, and we see that we're going to get 235.4 degrees. So from this part of the equation, we are going to get that theta is equal to 55.4 degrees or 235.4 degrees. Next, we turn to the second piece of the equation here, and here the tangent is negative. So when we draw our picture, we know that means that theta has to be in quadrant 2 or quadrant 4. Now here, if we do the tangent inverse of negative 3.4494, we can enter that in our calculator by hitting second, tangent inverse, memory variable, cursor over to the B, hit enter, close your parenthesis, hit enter, and we see that we get negative 73.8 degrees. Now, you have to recognize that this is not one of your answers. And this is because the calculator only knows that tangent inverse lives from, in degrees, negative 90 to positive 90. And that's all your calculator is able to output. But from this, we know that if our angle here was negative 73.8 degrees, while we know we can't use a negative angle because we are required to give our answers between 0 and 360 degrees, which means they all have to be positive, this tells us that our reference angle is going to be 73.8 degrees. Now, if we put that in our picture, then we know that our quadrant 2 angle, we would do 180 minus 73.8. And if we punch that into our calculator, we see we're going to get 106.2 degrees. So that's here in quadrant 2, 106.2 degrees. To get our quadrant 4 angle, we have to put the reference angle here. And we know that we're going to be taking 360 degrees and subtracting 73.8 degrees. Now entering that into our calculator, we see that we're going to get 286.2 degrees, and we can put that in our picture. So that means solving this piece of the equation gave us two more angles, and theta would have to equal 106.2 degrees or 286.2 degrees. So there were four different solutions to our original equation.